Hello everyone, welcome to my channel GVS Chem. This video explains about the solubility of a solid in a liquid and factors affecting it. Please share, subscribe and comment my videos. Now let us discuss solubility of a solution. Solubility of a solution. Different substances soluble to different extents in the same solvent. That is, solubility means the extent to which the solute dissolves in a fixed amount of definite amount of solvent is known as solubility. So the extent to which the solute dissolves in a definite amount of solvent is called solubility. Solubility can be defined in another way also, that is, or the amount of solute means maximum amount of solute that can be dissolved in 100 gram of solvent is called solubility. So another way of expressing the solubility is the way of expressing the solubility. The way of expressing solubility is mole per decimeter cube. Decimeter cube means it is nothing but 1 liter, or gram per decimeter cube, mole per decimeter cube or gram per decimeter cube, or so expressing solubility is mole per decimeter cube or gram per decimeter cube or gram per 100 gram of solvent, that is number of grams of solute per 100 gram of solvent. So solubility can be calculated, solubility equal to mass of solute by mass of solvent into 100. Mass of solute by mass of solvent into 100. That is the solubility. How solubility occurs? Solubility of a solute occurs, how it occurs in a solvent. The process of solubility. See, when a substance is dissolved in, say, water is a universal solvent. When a solute is dissolved in solvent, what happens? We know that the molecules move at random in all directions. So, when a solute is kept in solvent molecules collide with the solute particles. Solvent particles collide with solute particles. Therefore, the interactions between the solute particles become weaker. Thus, interactions between solute particles become weaker. Interactions between solute particles become weaker, therefore the solute particles are separated. Solute particles are separated from each other. Solute particles are separated from each other. Thus what happens? Solute particles will mix among the solvent particles. Thus, solute particles mix among the solvent particles. Hence, solubility. So, solute particles mix among the solvent particles. Hence, it is solubility. Now, let us discuss the solubility in terms of interactions of solute particles and solvent particles. If the solute B dissolves in solvent A, then there are 3 types of forces. The 3 types of forces are AA forces. AA forces means solvent interactions. That means the interactions between solvent particles. Interactions between solvent solvent interactions. And the next one is solute. This is solvent, this is solute. So BB interactions, that is solute interactions. Solute interactions. Solute interactions. So if a solute is kept in solvent, then what happens? The original interactions, that is AA interactions and BB interactions, they break and new interactions form between A particles and B particles. So when a solute is kept in solvent, AA and BB interactions break and new interactions are formed. Hence solute is soluble in water. Hence solute is soluble in water. If a solute is kept in solvent, that is just now we discussed that AA interactions and BB interactions become weaker, and finally new interactions between particles of solute particles B and solvent particles A, new interactions will develop, and of course solubility or solute is soluble in solvent. Now here this is a beaker in which water. Now let us keep a speck of salt. This is salt. So what happens? This salt dissolves in water. So solid changes to aqueous form. Solid changes to aqueous form. Now what happens if we keep some more salt? That also dissolves. If we keep some more salt, that also dissolves. So what happens here? Solid plus solvent becomes solution. So when we go on adding the salt in little quantities, what happens after some time? The solution changes to solute and solvent. This is solute. Solution changes to solvent and solute, which we called as a crystallization. So solution gives solute plus solvent. This is crystallization. Crystallization means settling of substance at the bottom. So after adding certain amount of solute in the given amount of solvent, what happens? It is observed that a fixed amount of solute is left at the bottom of the solution. That means solubility is going on, and at the same time crystallization is also going on. That is, solute continuously dissolves in solvent to form solution. Simultaneously, solution dissociates into solute and solvent continuously. So at certain time these two processes go in equal rates. Therefore we say that there exists an equilibrium between solute and solvent and solution. So this is solute plus solvent gives, so this is an equilibrium. Equilibrium is represented by double-headed arrow. So this is solution. So forward reaction is solubility and backward reaction is crystallization. And of course this equilibrium, it can be shifted. If we add more amount of solute to the solvent, then what happens? The forward reaction goes faster, that is equilibrium shifts to right side. In the same manner, if some amount of solute is taken out, that is crystallized solute is taken out, then backward reaction takes place. Therefore such an equilibrium is referred as a dynamic equilibrium. That is, this equilibrium can be shifted to either right side or left side. Therefore this equilibrium is referred as a dynamic equilibrium. So this equilibrium can be shifted to either side. Therefore, this is called dynamic equilibrium. Dynamic equilibrium. So when equilibrium is reached, the fixed amount of solvent contains maximum amount of solid. That means that in a fixed amount of solvent, a fixed amount of solute is dissolved, and of course that is in such a case the solution is referred as a saturated solution. Saturated solution means a solution in which no more solute can be dissolved. That means even if we add the more amount of solute into the solution, that does not dissolve. That does not dissolve means it appears that it does not dissolve, but actually what will happen? Solubility takes place, and of course crystallization takes place. So continuously these two processes take place. But out in saturated solution, the number of solute particles going into the solution becomes equal to the number of dissolved solute particles crystallizes and settling at the bottom. That is, the process of solubility is equal to the process of crystallization. So saturated solution can be defined as a solute in which no more solute can be dissolved at a definite temperature or particular temperature. Here temperature is constant. So let us see the definition of saturated solution. So a solution in which no more solute can be dissolved at a given temperature is called saturated solution. As we define saturated solution, there is unsaturated solution. So what is unsaturated solution? A solution which can dissolve more amount of solute in it. Whatever be the amount additionally dissolved, it may be 1 gram or it may be more than 1 gram. So such a solution is known as an unsaturated solution. An unsaturated solution is that in which more amount of solute can be dissolved. Now if we prepare a saturated solution at certain temperature, and if we increase the temperature, then what happens? In most of the cases, more amount of solute is dissolved. That means, if a solution is made saturated at certain temperature, then it becomes unsaturated at a higher temperature. So, a saturated solution may become a saturated solution at a certain temperature. A saturated solution at a certain temperature may become unsaturated at higher temperatures. Unsaturated at a higher temperature. So a saturated solution at a certain temperature may become unsaturated at higher temperatures. Now let us see the cause of solubility of solids in liquids. The cause of solubility of solids in liquids. See, just now we discussed that there are interactions, solute interactions and solvent interactions, and if these interactions AA and BB interactions break and new interactions, that is AB interactions, will develop, therefore solubility takes place. Then what causes the break of original interactions and what causes to form new interactions? So this depends on the general statement that like dissolves like. Like dissolves like. What does it mean, like dissolves like? Means polar compounds, polar solutes, we can say. Polar solutes dissolve in polar solvents like water. Polar solvents. What are polar solutes? Polar solutes means nothing but ionic substances. Ionic substances. What are the ionic substances? Best example is NaCl, KCl. Of course, NaOH, sodium hydroxide, CaOH twice, and HCl. HCl does not have ionic bond, but it has polar covalent bond. Therefore, it is a polar solute. And polar solvents, the polar solvent is water. So water is a polar solvent. So ionic polar solutes like ionic substances or polar covalent substances dissolve in polar solvents like water. On the other hand, non-polar solutes like sulfur, iodine, camphor, etc. They are non-polar solutes. They dissolve in non-polar solvents. Non-polar solvents like benzene, C6H6, CCl4 carbon tetrachloride, CS2 carbon disulfide, etc. So these two like dissolves like. Whereas if we keep say NaCl in benzene, C6H6, no solubility, does not dissolve. Polar solutes do not dissolve in non-polar solvents. In the same manner, non-polar solutes like sulfur, iodine, etc., they do not dissolve in polar solvents like water. So this is the statement like dissolves like. So this in these pairs of cases, what happens? Old interactions will break and new interactions will form. So if ionic substance is kept in water, what happens? Say sodium chloride, Na plus and Cl minus. So what is this ion-ion interactions? It has ion-ion interactions. Ion-ion interactions. Water, hydrogen. Water has polar covalent substance, therefore it is partial negative charge and partial positive charge, and here also in this way. So what happens? What do you call this bond? Hydrogen bond. Hydrogen bond is formed. Now when sodium chloride is kept in water, what happens here? Here it is plus. This negatively charged ion attracts towards the positively charged hydrogen. Negatively charged chloride attracts towards the positively charged hydrogen. In the same way, positively charged hydrogen, sodium, attracts towards a negatively charged oxygen. Due to this, what happens? The strong electrostatic attractions breaks and new attractions will form. Thus what happens? This is water molecules around. Due to this process, this is sodium. So around the sodium, water molecules surround in this manner. So this is plus. In the same manner, here this is chloride. Around the chloride also water molecules surround. So this surrounding of water molecules around the differently charged ions is referred as hydration. This is known as a hydration. So the process of surrounding of water molecules around the oppositely charged ions is called hydration, and of course during hydration certain amount of energy releases, which we call it as hydration energy. So hydration energy is defined as the amount of energy releases during the hydration of 1 mole of ions. So the amount of energy released during the hydration of particles released by 1 mole of substance. That means 1 mole of ionic substance release 1 mole of sodium ions and 1 mole of chloride ions. So the amount of energy released during the hydration of 1 mole particles released by 1 mole of substance, and that is known as hydration energy. And this hydration energy is represented as delta H hydration. HYD means hydration. Delta H hydration, that is hydration energy. When ionic substance is kept in water, what happens? The old interactions break. That means interactions between oppositely charged ions, that is electrostatic interactions, will break. To break the electrostatic interactions, certain amount of energy should be supplied. Therefore, the amount of energy required to break 1 mole of ionic substance into its constituent ions is known as lattice energy. So this is lattice energy. So lattice energy lattice energy is the amount of energy that is required to break 1 mole of ionic substance into its constituent ions. And it is represented as, and it is shown as delta LH. Delta LH means lattice enthalpy, or enthalpy change taking place during the breaking of 1 mole of an ionic substance into its constituent ions is known as lattice enthalpy, hydration enthalpy and lattice enthalpy. Now, if hydration enthalpy is greater than lattice enthalpy, then what happens? Dissolution takes place with the release of energy. So, if hydration enthalpy is greater than lattice enthalpy, then dissolution takes place with delta H is less than 0. That means energy releases. That means during the dissolution process energy releases. Therefore, such a dissolution is known as exothermic. So this is exothermic. Now, if delta H hydration, enthalpy of hydration is less than enthalpy of lattice enthalpy. If enthalpy of hydration is less than enthalpy of lattice enthalpy, but if delta S is positive, then what happens? Then also dissolution takes place. Dissolution takes place with absorption of energy. That is, delta H is positive. That means here the dissolution process is endothermic process. That means when a solid solute is dissolved in water, what happens? It takes the required amount of energy from the surroundings. Therefore, what happens? That is an endothermic process. For example, if ammonium chloride is dissolved in water, you take one test tube full of water and add a little amount of ammonium chloride and touch the test tube becomes cold. That means it took the energy from the surroundings. So such a process is known as a endothermic process. If lattice enthalpy is not compensated by enthalpy of hydration, if lattice enthalpy is not compensated by hydration enthalpy, then dissolution does not take place. Therefore, the net result is, so during the dissolution process, the energy changes taking place is known as enthalpy of solution. So enthalpy of solution is delta H solution. So what happens if delta H hydration is greater than lattice enthalpy? Then what happens? Delta H solution is negative. If delta H hydration is less than lattice enthalpy, then delta H solution is positive. That means the difference between these two is very less. In such cases, what happens? Delta enthalpy of solution is positive. Therefore, dissolution takes place with the absorption of energy. If hydration enthalpy is not compensated to lattice enthalpy, then dissolution does not take place. Factors affecting the solubility of a solid in liquid. So what are the factors that affect the solubility? That means under what conditions the solute dissolves to large extent, under what conditions the solute dissolves to less extent. So the factors is nature of solute and solvent. So this we discussed already, that is like dissolves like. That is ionic substances are soluble in polar solvents like water, and non-polar solutes dissolve in non-polar solvents like benzene, CCl4, CS2, etc. Therefore, ionic or polar solutes dissolves in polar solvents. Example, NaCl, NaOH, KNO3, etc. dissolve in water. Non-polar solutes like, what are the non-polar solutes? Sulfur, iodine, camphor. They dissolve in non-polar solvents. Non-polar solvents. What are non-polar solvents? Benzene, CS2, CCl4, etc. So non-polar solvents dissolve in non-polar solvents. Non-polar solutes dissolve in non-polar solvents. So this is the nature of the solute and solvent. The next one is temperature. Effect of temperature. If a solute is dissolved in solvent, then solution is formed, and of course it is equilibrium. So solute plus solvent gives solution. So solute plus solvent gives solution if delta H solution is negative, that is dissolution is exothermic, that is release of heat. If temperature increases, if factors like pressure, temperature, pressure, etc. increases on equilibrium, then Le-Chatelier principle says that the equilibrium shifts to such a direction where the effect is nullified or where the effect is compensated. So if the temperature increases, since it is exothermic reaction, the backward reaction favors, that is dissolution becomes less. So according to Le-Chatelier principle, equilibrium shifts to backside or backward direction. Equilibrium shifts to backward direction, that is solubility decreases. On the other hand, solute plus solution, solute plus solvent gives solution. Delta H solution is positive, greater than 0. Therefore, what is this reaction? This is endothermic reaction. Endothermic reaction means absorbs heat. So if the dissolution process absorbs heat, the increase in temperature will favor the forward reaction. That means solubility increases. So more amount of solute can be dissolved in solvent at a higher temperature. So in this way we can discuss the effect of temperature. So lithium sulfate, sodium sulfate, these substances, they increase the solubility with decrease in temperature. Increase the solubility with decrease in temperature. KCl, KNO3, etc. increase the solubility with increase in temperature. Let us summarize the solubility with respect to temperature. Solute plus solvent gives solution and temperature effect and how the solubility changes. If delta H is less than 0 or negative, that is energy releases during the dissolving of a solid in the liquid. Therefore, the solubility is exothermic. If temperature increases, solubility decreases. Example, lithium sulfate, sodium sulfate, etc. Such salts, they decrease their solubility on increasing the temperature. On the other hand, if delta H is greater than 0
or delta H is positive, then heat is absorbed during the dissolving of a solid in the liquid. That is, the solubility is endothermic. That is, for this type of solutions, if the temperature increases, solubility increases. For example, KCl, KNO3, potassium chloride, potassium nitrate, sodium nitrate, etc. They increase the solubility due when temperature increases.
These solubility curves. Now let us discuss the solubility curves. Solubility curve of any substance is a graph plotted between temperature and its solubility. So here in this figure we have solubilities of different substances. So here what happens as the temperature increases, solubility of potassium nitrate, sodium chlorate, lead nitrate, etc. they increased. Potassium nitrate increased to very maximum extent. There are certain substances like sodium sulfate. Solubility of sodium sulfate decreases. Solubility of sodium chloride is almost fixed or constant at the temperature. That means even if the temperature increases, solubility does not increase to much extent. And of course, certain substances like sodium sulfate 10H2O, sodium sulfate decahydrate, up to certain temperature, what happens? Solubility increases and thereafter it decreases. Then what is the purpose of solubility curve? By using the solubility curve, we can find the solubility of any substance at the given temperature. So solubility curves help us to find solubility of any substance at any temperature. So this is the purpose of the solubility curves.
Thank you. Students are advised to revise this lesson and prepare well for examination.